In this video, we'll take a look at section 5.5, which is solving rational equations. Now, our first objective, we're going to solve rational equations. Now, what this means is we're going to have equations that have fractions in it. So just like what we saw before in chapter 1, in order to solve equations with fractions, what we can do is get rid of the fractions. So we can get rid of the fractions and then we'll be left with an equation that's much simpler to solve. So here's the steps. First, you're going to find the LCD. Then you're going to multiply each side of the equation by the LCD. Then step 3, solve the remaining equation. So after step 2, when you multiply each side of the equation by the LCD, you won't have any more fractions in that equation. So then you'll solve that remaining equation. And then step 4, you have to check for any solutions that make the original equation undefined. Meaning if you end up with the result and if you plugged it in and it makes the denominator 0, that would make it undefined, which means you have to get rid of that solution. You have to cross that one out. Okay, let's take a look at an example. So solve each equation. We have 2 over 3 plus 5 over 6 is equal to 1 over x. So I have this equation. I have a lot of fractions in the equation. So first I want to figure out what the LCD is. So to find out the LCD, just like what we saw when we were adding and subtracting rational expressions with unlike denominators, let's factor out each one of the denominators. So we have 3 is only 3. 6 I can rewrite as 2 times 3. And now my x is just x. And now we start circling the most amount of times that each factor appears. So now one of my factors is 3. This appears once in the first list and once in the second list. So we're just going to circle one of those. Another factor that we have is 2. It only appears once in the second list, so let's circle that 2. And then we have x. So our LCD here is 3 times 2 times x, which gives us 6x. Okay, perfect. That was step 1. We found out our LCD. Now we're going to multiply each side of the equation by the LCD. Now when you multiply each side of the equation by the LCD, it's essentially the same as just multiplying each term by the LCD. So let's go ahead and multiply each term by the LCD. So we have 6x times 2 over 3 plus 6x times 5 over 6 equal to 6x times 1 over x. Now with each one of these fractions, first I'm going to put my 6x as over 1. So now we have a fraction times a fraction. Now with each one of these multiplications, we can cross cancel in each case. So for the first one, 3 goes into 3 once, it goes into 6 2 times. So all I'm left with there is 2x times 2x times 2, which gives me 4x. Next part, 6 and 6 cancel out with each other. I'm left with x times 5, which gives me 5x. And now on the right hand side, my x's cancel out with each other. I have 6 times 1, which gives me 6. So now I have this linear equation without any fractions. So let's go ahead and solve. So let's combine like terms. 4x plus 5x, that gives me 9x, and I have equal to 6. And the next step to solve for x, go ahead and divide both sides by 9. I get x is equal to 2/3. Next, we have to check our solution just to make sure it doesn't give us a 0 in the denominator. Okay, so let's go ahead and check that real quick. Let me just fix this writing. So we had 9x equals 6, and then we divided both sides by 9. We got x is equal to 2/3. Okay, so I want to check the solution that we got into our original, I want to plug it into my original problem. But I'm not going to plug it in completely. I just want to check if I plugged it in for my x, does it give me a 0 in the denominator? Well, the value that we got for x is 2/3. So I'd have 1 divided by 2/3, which is fine. If I ended up with 1 divided by 0, then we have a problem. We'd have to get rid of that solution. So x equals 2/3 is okay. This is our final answer. Let's take a look at another problem. So solve each equation. We have 4 over 3y minus 3 over y is equal to 10 over 3. Okay. Well, first let's go ahead and find the LCD. So 3 times y, this is just 3 times y. My y can't factor that out, it's just y. And then 3 is just 3. So let's circle the most amount of times each factor appears. Well, 3 appears once in the numerator, or once in the first list, once in the third list. So most amount of times it appears just once. Y, once in the first list, once in the second list. So we just circle one of the y's. So our LCD here is 3y. So let's go ahead and multiply each one of these by 3y. So I have 3y times 4 over 3y. I have minus 3y times 3 over y. And I have equal to 3y times 10 over 3. Okay, let's go ahead and change all these 3y's into fractions, put a 1 underneath them. And now we could cross cancel with each one of these. So cross canceling, okay, 3 cancels out, and y also cancels out, leaving me with just 4. Next set of fractions, y's are going to cancel out. I have negative 3 times 3, which gives me negative 9, so I'm going to have minus 9, and I have equal to. And then on the right hand side, 3's cancel out. I have y times 10, which gives me 10y. Now let's continue to solve. So this gives me negative 5 is equal to 10y. And now let's go ahead and divide both sides by 10. So we get y is equal to negative 1 over 2. So we have negative 5 over 10, which simplifies into negative 1 over 2. Now just check, make sure it doesn't give you a 0 in the denominator. Well, if I plugged it in for either one of these y's, so 3 times negative 1/2 gives me negative 3/2, which is okay. 4 divided by negative 3/2, it's not undefined. And the same thing with the other one, 3 divided by negative 1/2, also not undefined. So y equals negative 1/2 would be our solution. Next problem. So solve the equation. We have x squared over x minus 3 equal to 9 over x minus 3. Okay, so first let's find our LCD. Now in this case it's a little bit easier because our denominators are the same. We have x minus 3 for each one. So our LCD here is x minus 3. So now let's go ahead and multiply each side of the equation by x minus 3. So I have x minus 3 times x squared over x minus 3 equal to, now the right hand side, x minus 3 times 9 over x minus 3. Let's go ahead and change these into fractions. And now once again we can cross cancel. Now whenever you multiply by the LCD, you'll be able to cross cancel with every fraction. So now all I'm left with here is x squared is equal to 9. So now I have this equation to solve. And now notice here we have a quadratic equation, since our x is being raised to the second power. So in order to solve this quadratic equation, we have to get into standard form. So get one side equal to 0. X squared minus 9 is equal to 0. And then once you get into standard form, you have to factor. X squared minus 9, this is a difference of 2 squares. This factors into x minus 3 times x plus 3. Now we go ahead, set each factor equal to 0, and then solve. So for the first equation, I get x is equal to 3. I add 3 to both sides. Second equation, I'm going to subtract 3 from both sides. I get x is equal to negative 3. So this time we get two solutions, but remember, check them, make sure it doesn't give you a 0 in the denominator. Let's take a look at this first one, x equals 3. If I plugged in 3 in for my x here, I get 3 minus 3, which gives me 0, which is in, so we have a 0 in the denominator, which is undefined. So this x equals 3, I have to get rid of this one. Next one, negative 3. Well, negative 3 minus 3, that just gives me negative 6. So that one's okay. That doesn't make it undefined. So our only solution in this case is x equals negative 3. Let's take a look at other examples. So to solve the equation, we have 4x over x plus 5 plus 20 over x equal to 100 over x squared plus 5x. Okay, so let's begin by finding out the LCD. So x plus 5 I can't factor, just leave it as x plus 5. X I can't factor either, just leave it as x. Now x squared plus 5x, I can factor out an x, and then I'm left with x plus 5. So now let's take a look at how many times a factor appears the most. So x plus 5, this is a whole factor. It appears once in the first list and once in the third list. So the most amount of times it appears is just one time. Circle one of them, and then the other factor that we have here is x. Most amount of times it appears is just once. It appears once in the second list and once in the third list. So we just circle one of them. So our LCD here is x times x plus 5. Now let's go ahead and multiply each side of the equation by our LCD. So we have x times x plus 5 times 4x over x plus 5 plus x times x plus 5 times 20 over x equal to, now the right hand side do the same thing, x times x plus 5 times 100 over, now for this last fraction, the denominator, I'm going to rewrite it in factored form. That way I can see what's going to cancel out. So let's put these as all over 1. So now we're multiplying two fractions. Now we could cross cancel. So x plus 5's cancel out. So I'm left with x times 4x, which gives me 4x squared. Next, my x's cancel out. I'm left with plus 20 times x plus 5. I have equal to. And now on the right hand side, the x's cancel out and the x plus 5 also cancels out, leaving me with just 100. So now I'm left with this equation. Let's go ahead and distribute. So we have 4x squared plus 20x plus 100 equal to 100. So we have a quadratic equation here. Let's get into standard form. So subtract 100 from both sides. We get 4x squared plus 20x. The 100 minus 100 cancels out, so I'll have to equal to 0. Now let's factor out the GCF. So we have a GCF of 4x, and we're left with x plus 5. We have equal to 0. Now set each factor equal to 0 and then solve. So we have 4x is equal to 0, and then x plus 5 is equal to 0. First equation, divide both sides by 4. You get x equals 0. Next equation, subtract 5 from both sides. You get x is equal to negative 5. So we get two solutions here, but just remember we have to check to see if it makes the denominator 0. So if I plugged in, let's go back to our original equation. So one of the solutions we got was x equals 0. Well, if x is equal to 0, it's going to make that denominator 0. So you'd have 20 divided by 0, which is undefined. So x equals 0, we have to cancel out. The other solution we got was x equals negative 5. Well, if x equals negative 5, let's take a look at this fraction. Negative 5 plus 5 gives me 0. So it makes the denominator 0 in that first fraction, which would make it undefined. So both of the solutions that we ended up with make the denominators 0. Makes the original equation undefined. So we have to cancel out both of them, which leaves us with no solution. Next example, okay, very similar. Let's go ahead and find out what the LCD is. So we have x squared minus 9. This is equal to, so we have to factor it out. This gives us x minus 3 times x plus 3. X minus 3, we can't factor that out. X plus 3, we can't factor that out either. Now we're going to circle the greatest amount of times that each factor appears in a single list. So first, x minus 3 appears once in the first, once in the second, so you just circle one of them. X plus 3 appears once in the first list and once on the third list, so you just circle one of them. So our LCD here is x minus 3 times x plus 3. Now let's go ahead and multiply both sides of the equation by the LCD. X minus 3 times x plus 3 times 2 over, and now for my first fraction I'm going to rewrite it in factored form. X minus 3 times x plus 3. That way I can see what cancels out. That plus, okay, x minus 3 times x plus 3 times 5 over x minus 3 equal to, same thing with the right hand side. Okay, now we can start canceling. Let's put these as all over 1. So x minus 3 cancels out, x plus 3 also cancels out, I'm just left with 2. Second set of fractions, x minus 3's cancel out, I'm left with plus 5 times x plus 3. I have equal to. And then on the right hand side, x plus 3's cancel out, I'm left with 3 times x minus 3. So let's go ahead and solve this equation. Let's get rid of these parentheses to start. So let's distribute. So we have 2 plus 5x plus 15 is equal to 3 times x, which is 3x, minus 3 times negative 3, which is negative 9. Now on the left hand side we have some like terms we could combine. So we have 5x plus 17 is equal to 3x minus 9. Now the equation that we have is just a linear equation. There's no x squared. So in order to solve this equation, let's move our x's to one side, move our constants to the other side. So I subtracted 3x from both sides, and then I subtracted 17 from both sides. So I end up with 2x is equal to, get negative 26. Now let's go ahead and divide both sides by 2. We get x is equal to negative 13. Now if we check it, it should be okay. So if I plug negative 13 into this first fraction, it doesn't give me a 0. The second fraction doesn't give me a 0. And then the third fraction, it doesn't give me a 0 in the denominator either. So x equals negative 13 is okay. Now, one last problem. So given that f of x is equal to x minus 12 over x, find all values of x for which f of x is equal to 1. Okay. Now let me rewrite this problem so we can see what's going on. Remember, f of x is just the same thing as y. So we have y is equal to x minus 12 over x, and it's telling us to find x when y is equal to 1. So there's a couple ways that we could work this out. There's a graphical approach and then the algebraic approach. So the graphical approach, we have to find out where y is equal to 1, which is indicated by this blue line right over here. So this is where y is equal to 1. We want to see where it crosses the graphs. So we have this point and then we have this point over here. Now be careful because the increments over here are by 2. So it's just like 2, 4, 6, 8, 10. And then the other side would be negative 2, negative 4, negative 6, negative 8, negative 10. So when we're looking at the graph, we can tell that, okay, x is equal to, so when y is 1, x is equal to 4, and x is equal to negative 3. So this is using a graphical approach. Now if we're using an algebraic approach, the way that we can work this out is go ahead, plug in 1 for your y, and then solve the equation. So we would have 1 is equal to, x minus 12 over x. And now we have to solve this equation. Well, notice we have a fraction. So let's go ahead and multiply by our LCD. So in this case, our LCD is just x, since all we have is that one fraction and the denominator is x. So let's go ahead and multiply each side of the equation by x, and then we'll work it out. So we have x times 1 is equal to x times x minus, and then x times 12 over x. Okay, now let's write out what's left over. Well, x times 1 gives me x. I have x is equal to, x times x gives me x squared. And for that last part, my x's cancel out. I'm left with minus 12. So I have this equation to solve, no more fractions. So we have an x squared in the problem, meaning we have a quadratic equation. So to solve quadratic equations, let's get one side equal to 0. So let's go ahead and subtract x from both sides. I get 0 is equal to, I have x squared minus x minus 12. And now we go ahead and factor. Well, I need two numbers that multiply to give me negative 12 and then add up to negative 1. So I could use negative 4 and 3, so x minus 4 and x plus 3. Now we go ahead and set each factor equal to 0 and then solve. The first equation, I'm going to add 4 to both sides. Second equation, I'm subtracting 3 from both sides. So we get x is equal to 4 and x is equal to negative 3. And notice that was the same results that we got using the graphical approach, where we just looked at the graph and determined what our solutions were. So that was it for section 5.5. Remember, if you have any questions, don't hesitate. Just email me and I'll help you out.